Welcome students, we have a question. This is Berkeley integration be inspired. It's a tiebreaker question given to the contestants. We expected to integrate this. Now foremost, before we could integrate this, we would want to know what happens if we were to be given integral 0 to 1 log x dx. Now whenever we have a function of this fashion, we would use the Liet method. L stands for log, I stands for inverse, A stands for algebraic function, T stands for trigonometric, E stands for exponential. Now this is the hierarchy in which U will be assigned. Take U to be as log x and dv to be equal to dx. So what I will do is I will have to differentiate U and integrate this dv. So if we were to differentiate u, it's going to be du is equal to differential of log x is 1 over x times dx, and integration of dv is going to be v, integration of dx is going to be x. So this is equal to uv negative integral v du. So this is the formula. Of course on the left hand side is going to be u dv, right, integral u dv, because u is log x and my dv is dx, right? So if you were to rewrite this or make the substitution, this is actually nothing but integral u is log x and dv is dx. So this is what we are integrating. On the right hand side, my u is log x, my v is x, I'm placing it here. The limits are 0 to 1, negative integral v is x and my du is dx over x. So x and x gets cancelled. This is equal to x times log x 0 to 1, and we got a negative sign followed by 0 to 1 dx, because the limits are 0 to 1. Now if you were to place the upper limit, it's 1, log 1 is going to be 0. Lower limit, you got x is equal to 0, so you get 0 there for that particular quantity present here, followed by integral of dx is going to be x, and limits are 0 to 1, so this is equal to negative of 1. Of course 0 is there, it's not going to matter. So this is what we have got. So what would be the situation if we were to be given 0 to 1 log x raised to the power of 2 times dx? What would be the state? Now when we were given log x with no exponent, that means exponent was just 1, we had the left hand side or the first term being totally annihilated because of the limits, and we just had the second term, or I would say the term that has the integral, and even in that case we totally lost x, right? So let us see what happens when we were given log x raised to the power of 2. So as usual, what I would do is I would just take, let u be equal to this quantity, so this is going to be log x raised to the power of 2, and my dv is going to be equal to dx. So if I were to differentiate this, I would get 2 times of log x raised to the power of 2 minus 1, that's going to be 1, times the differential of log x, that's going to be 1 over x. So this is going to be 2 log x over x. So this is for my du. Now as far as my dv is concerned, if I were to integrate this, I get v is equal to x. So of course I need to place dx over here whenever I differentiate. That's important. So formula uv negative integral v du, this is equal to u, my u is log x raised to the power of 2, my v is going to be x. So let me just place it, and the limits are 0 to 1. negative integral, my v is x, my du is going to be 2 times log x divided by x. Let me write it like this, dx. So my x and x gets cancelled. This is equal to, this is going to be 0 followed by a negative sign. So I'm getting 2 times of integral log x times dx, right? So this is a very important point you have to note. Now moving on, I'm not going to apply the limits. The limits, because this is nothing but the same quantity which we started here, right? 0 to 1, not this one, I should say this one. This is the one we started, right? This was 0 to 1 log x dx, and we solved it in this fashion. So now, when we were given log x raised to the power of 2, this was the quantity that totally boiled down, or I should say that resulted. Now let me go a little bit further. So this is the third one, so this is the second one, the first one, right? I'm starting from degree 1, 2 to degree 3. So I get log x raised to the power of 3 times dx. So in this case my u is going to be log x raised to the power of 3, my dv is equal to dx. So I differentiate, I get 3 times log x raised to the power of 2 times differential of x is 1 over x times dx, and my v is going to be x. So formula uv negative integral v du, what do I get? My u is log x raised to the power of 3, my v is x, I place my x here, the limits are 0 to 1, negative integral v is x, my du is 3 times log x raised to the power of 2 over x times dx. So x and x gets cancelled. Now this is going to be 0. Now this is going to be negative 3 times integral, of course the limits are 0 to 1, 0 to 1, log x raised to the power of 2 times dx. Now watch here, this is 3 times log x raised to the power of 2, this is 2 times log x raised to the power of 1, right? And the starting one, the beginning one, this is log x raised to the power of 0, right? The degree vanishes here, so just the quantity dx remaining here. In this case the degree is 1, with the 2 being pre-multiplied, and in this case it's going to be 3 and the degree being equal to 2. So we are given, what are we given? We are given integral 0 to 1 log x raised to the power of 2024 dx. So what would this be? Now just consider this one. Now I can very well rewrite this one as negative 3. I can take negative 3 out, and I have integral 0 to 1 log x raised to the power of 2 dx. Right? Now let me use the space here. Let me try to explain the concept here. So negative 3. Now this is actually this. But what is that? It's going to be negative 2 times integral 0 to 1 log x dx, right? But what is this? This is actually this. And what was that? That's nothing but negative dx. So this is going to be negative 3 multiplied with negative 2 times integral 0 to 1 dx. So clearly you can see the degrees are actually pre-multiplied and they are in a reducing fashion. So finally we are actually reaching 0 to 1 dx. So the idea here is, if we were given integral 0 to 1 log x raised to the power 2024, we would have a quantity like this, 2024 negative sign times negative 2023 times negative 2019 times negative 2018 times negative 2017 times negative 2 0 16 times, and so on, so on, so on, so on it will go. Finally it will end with -1, right? This is the final outcome that we will land here. So now what is this? This is nothing but 2024 factorial.